Welcome, dear children. This is Rita Miss. Now we'll take the third example, which is there on page number 4. Now the question given here is ABCD is a parallelogram and P is on the side BC. So what is a parallelogram? Parallelogram is a figure or a quadrilateral which has got 4 sides and your opposite sides are parallel. Okay. And this one looks like rectangle, but parallelogram you have opposite sides parallel. Okay. And what is parallel? Parallel means it does not meet at any point. Now whenever we say about parallel, we will take the example of the railway tracks. The railway tracks never meet each other, right? So this parallelogram is opposite sides are parallel. Now you have A, D is here, C is here and B is here. Now all the triangles which are there, which are drawn between these two parallel lines, AD and BC, they are drawn between them. So the distance between the parallel lines are the same. As I said, the parallel lines never meet, so the distance remains the same throughout. Okay, it remains the same. So naturally, when the figure is drawn, that means the figure, that is a triangle which is drawn between the parallel lines, the distance between the parallel lines is the same. So naturally, the height will be the same. So for the entire thing, all the triangles which are there, whether it is ABP or BDC or APC, any triangle you take, the height will be the same. Okay, so the condition was that ABCD is a parallelogram, P is on the side of BC, P is here. Now what do we have to find? We have to find two pairs of triangles with equal area. So from this many triangles which are there, how many triangles? You'll just count how many triangles and name the triangles. And I'll help you. ABC is one triangle. Okay. Then you have BDP. Then you have PDC. There are so many. The diagram is going to get untidy. So we'll just take the triangles and then we'll try to find out which are the triangles whose areas are equal. So in order to find the area, we have to find the base and height. So before we go, we'll just revise the concept. What is the thing? ABCD is a parallelogram, right? It's given in the question, and opposite sides are parallel. So which opposite sides are parallel? AD is parallel to BC and AB is parallel to DC. So the opposite sides are parallel and distance between the parallel sides are same. Okay, the distance between the parallel sides are same. And since triangles are drawn between parallel lines, since all the triangles are drawn between the parallel lines, therefore the height of all the triangles are equal. Okay, just cancel off this word. Height of all the triangles are equal. So here we have got the condition that the heights are equal. So naturally now we have to look at the base. So let's take the first triangle. We are taking triangle ABC. From here we are taking ABC. Okay, ABC. It's here. I have drawn it separately here. And the next one is BDC. BDC. Okay. The thing is, one is an acute angle triangle. What's an acute angle triangle? One is an acute angle triangle, the other one is an obtuse angle triangle. ABC is an acute angle triangle. Now, as you said that all the heights are the same, now we're going to take this as the height. This as the height. Okay. So here the base is in triangle ABC, base is BC. Okay, and height is, we'll take this only. Height is H. All have the same height, whether we draw it here or we draw it here, it's going to be the same. In the case of an acute angle, you can actually draw the height here, but we'll take it, since all the heights are same, height of all the triangles are the same, we will take a common height, which is this one, h. So base is BC of triangle ABC, base is BC and height is common as h. And in this triangle BDC, here you have BDC. Now this is an obtuse angle triangle. As I told you earlier, obtuse angle triangle, you will have the height outside. Anyway, the height is h only for all the triangles since it is drawn between two parallel lines. So base is BC, again base is BC, height is h. Now how do we find the area of a triangle? We can use half base into height. A1 is equal to half base into height, and we will take A1 as triangle ABC. So how do you find the area of triangle ABC? Half into base is BC, and what is height? Height is h. Okay, this will take it as first equation. And next we will take area of triangle, next triangle BDC. BDC. Again half into, what is the base? Base is BC and of course height is the same. Now if you compare equation number 2 and equation number 1, you can find that they are same. Therefore these two things are equal. Okay, now suppose base is 5 and this is 6. This is 5 and this is 6. Naturally everything is same for both the things, both the triangles, the measurements are the same. Therefore we have found the first triangle. Area of triangle ABC is equal to area of triangle BDC. So we have found the first triangle. Okay, we have to find two pairs. So one pair we have found, and now we'll revise once again and then we'll go to the next pair. Okay, so here you are using the formula area of a triangle. How will you find half into base into height? So what is the base? So let's take the base. Base is BC of triangle ABC. Height is for everything it is h. This one h. And for BDC again you have h only here, common height. So base is BC and height is h. The area of triangle ABC is equal to half into BC into h. BC is base and h is height. Area of triangle BDC is half into BC into h, again same thing. Here also base is BC and height is h. Now from 1 and 2, if you compare these two, naturally a triangle ABC is equal to triangle BDC. Now how do you get it? Now suppose I will say that A is 5 and B is 5. Okay, then what is it? That means A is equal to B, right? If the value of A is 5 and the value of B is 5, that means A is equal to B. Similarly, when you are found at the right hand side, both the right hand sides are equal. Therefore, the left hand side, both of them will be equal. Therefore, area of triangle ABC is equal to area of triangle BDC. Now, why these two triangles are congruent? Because triangle ABC and BDC has common base. They have common base BC and BC, and also they have equal heights. Okay, so we have found the first pair, which is area of triangle ABC is equal to area of triangle BDC. Now we have found the first one, this one we have found, and now we'll find the second one, that is ABC and ABD. Now what is ABC? ABC, what is the base? Now remember we're going to take the base like this here. AB as the base. AB is the base. Okay, don't get confused. We'll say that earlier we took it as BC as the base, but here we're going to take AB as the base, and here also you will find that they have the same base. So you can look at a triangle from any angle, right? So if you're taking this as the base, for ABC, base is AB, and for ABD also base is AB. As we said earlier, the height is the same. Okay, height is the same for both the triangles. Okay, and now since AB is common in both, that means AB that is the common base and heights are equal. because the triangles are drawn between two parallel lines. Therefore, triangle ABC is equal to triangle ABD. I hope you all have understood. Don't get confused. You have taken the base like this. You can turn around and make AB as the base. Now this was ABC, right? I can make it like this, A, B and C. So here my base is AB. Okay. And my base is here. The other base is also AB. That is why the triangles are congruent. And the base is also equal and the height is also equal. Now here in this triangle, if you look at this figure, you can find that ABC is here, right? And ABD, again we are taking from here only. See, this line has come twice. A, B and it is going here. Okay, my lines are very crooked. Don't bother, that is why I have drawn it. So here you can see that the base is similar. So naturally we have got the answer, which are the two pairs of triangles which are equal. That is ABC is equal to BDC and ABC is equal to ABD. So I hope you all have understood. Don't get confused. Only thing to remember the concept that the triangle is drawn between the two parallel lines. Okay, so the heights are equal and the bases are common for both the triangles. So naturally, the two pairs of triangles are congruent. In the next video, we'll understand solved example 4, which will be the last solved example before practice set 1.1. So thank you, dear children, and God bless you.